5 into 2 parts. So we are continuing with logarithms. It will feel like we're still in the same chapter. We just split it into 2 parts because it could get tedious if we didn't. We need to stop and make sure we understood the first part before we moved on to the second part. Your tests are graded in an Edline. I do expect to be able to hand them back to you tomorrow. I have a few people who still need to test. So, but as far as the grade goes, they are in Edline. Check that and you can see what your grade is. And we should get those back tomorrow. Okay, so I encourage you to try to do this without a calculator. Just to practice what it means to be a logarithm and that information. No, I'm not about to take your calculators away. Isn't going to happen. Let's try it. So the first thing I'm going to do, if I wanted to try to do this by hand, is do what? Rewrite it, correct? 10 to the x power. So side note, computer's moving really slow. 10 I may have to just move up there. 10 to the x equals the cube root of 10. Well, what power makes a cube root? A fraction. Which kind of fraction? 1/3. I guess. The reciprocal of the root. Is that what your calculator said? 0.3 repeating, maybe? That makes sense, but where was it coming from? It was that property of exponents. 4, so what power is a half? Well, first, how do you get it to flip down? What kind of exponents make you have a reciprocal? Negative. Negative exponent would make it 1/4, right? Everyone agree? So x is negative. I know that much. If it were 2, wouldn't it square the 4? So it would be 1/16. 1/2. Why 1/2? What's a 1/2 do? What did a 1/3 do? Okay, good. A 1/2 square root. So 1/3 cube rooted, a 1/2 square root. So the square root of 4 is 2. And then to make it on the bottom, you would do a negative. And the last one. 3. So what power is 1/27? So -3. Why -3? Negative flips it, and then 3 cubed is 27. So just some brain work this morning. You can always do these in the calculator, but just get your brain. No. If you were in pre-cal, that would be a completely different story. So today we're going to learn some properties of logarithms. So we haven't dealt with our 2 logarithms added together, 2 logarithms subtracted. We've only just had 1 logarithm equals a number or 1 logarithm equals another logarithm. So we need a way to work with other things. And so we're going to look at some properties of logarithms. This does need to go on a note card. If you were to take like pre-cal or AP Algebra 2 or calculus, those you would have to do it without a calculator. Anything else, like college algebra generally. Every now and again in college, they will have a college algebra class where you'll get a mean professor that won't let you use one, but most college algebra. I say that, but that's rare. It could toss up if you took this in college. It could be non-calculators. Taking it here, you don't have to worry about that. Because Arkansas Tech does not take away your calculator. Michaela, she asked a question, but inside I guess. Wanted to hear that answer.
Wait, Arkansas Tech doesn't.
Yeah, on the final, they let you use calculator on the whole thing. So that's why I let you use a calculator on the whole thing. Because we practice how we play. Now, my AP Calculus class is a completely different story because half of the AP Calculus exam is not calculus. Any set of material could fall either place. But there are practice tests that we look at that have, there's a multiple choice calculator part and a multiple choice non-calculator, and an open response calculator and open response non-calculator. And we get pretty familiar with flip all square. A little bit still no. What number are we on? I am going to explain these. I just wanted to give you time to write first. Title this note card Properties of Logarithms. Properties of Logarithms. Left shoe. What number are you looking for? That part should, I think that makes you already put that on a note card, but if you don't have it on a note card, put it on this one. Or just put it on this one just for the fun of it. What is that thing over in the right? It's the circle thing, it's the conversion. So I think I already made you put that on a note card, but if you don't have it, put it on this one. It needs to be somewhere on the note card. And you see how those note cards are going to be helpful when you start doing those final review questions? It wouldn't be a bad idea. She said she needed to start doing this in other classes. Oh, you do it in other classes. It's not a bad idea. Pull the most important things from each chapter and put them in a concise location where you can find them. Because, yeah, the review you may not know how to do, though. It's usually just silly questions. I will be here. I will be gone while you're reviewing. So you'll have to stand on your own a little. Brooks.
I don't know.
Me neither. I mean, I know so. I've heard the name. The pretty great football player. So it's not like I've never had a student. Okay, let's talk about these. Number one. Why? Why? Number one, why? Anything to the zero power is always 1, right? So that makes sense. It doesn't matter what the base is, log base b of 1 is always equal to 0. Log base b of b is 1. Why? Anything to the first power is b, right? Anything to the first power is itself. Okay, let's look at the next one. B to what power equals b to the x? Well, b to the x equals b to the x, right? So log base b of b to the x is just x. In other words, log base b and b to the x cancel. Did we know that already? We did, because they're defined to be inverses, so that makes perfect sense, doesn't it? That's good to know. That things make sense. If log base b of x equals log base b of y, then x and y have to be. The next one is not quite as obvious, but I want to remind you of an equivalent exponent property. When you have two things with the same base that are multiplied together, don't you add the exponents? Aren't logarithms exponents? They're defined to be the power. So if you have log base b of u times b, that can be rewritten to be log base b of u plus log base b of v. You will need to memorize that for the test. And then log base b of u divided by v. There's an equivalent exponent property to that, isn't there? Subtraction. Log base b of u minus log base b of v is equivalent to that. And then, what happened when you had a power raised to a power? In exponents. You multiplied them, right? So I have log base b of u to the n is equivalent to n times log base b of u. So you can multiply that power in front. So these are some properties of logarithms that we're going to be working with over the next few days. So this says evaluate the logarithm. Of course, we could type it in our calculator. I know that I could do that. But I'm going to try not to, just for fun. Could I rewrite this? Using one of the properties. Which property? The subtraction and divide one. This is the right-hand side of that property. Everyone agree? So going back to the left-hand side, I can write this as a single logarithm. I do want you to know that this is not the same as log base 2 of 160 over log base 2 of 5. That is not the correct way to work with the property. Make sure you follow the property exactly. Which right now you know that because you're looking at it. Just be careful, that's a common mistake. What is 160 divided by 5? 32. So this is log base 2 of 32. 2 to what power is 32? That's something I can do. It may take you a second, but 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, right? 5. Type that in your calculator. Do you get 5? It doesn't matter which way you type it in, you get 5. So we're noticing some properties that are
So,
true.
like 160 is on.
No.
So how do you know which one?
The one that has a minus. What do you know about negative exponents? In exponent properties. Negative exponents go on the bottom. So negative logarithms go on the bottom. So negative logarithms go on the bottom. Okay, good question. Because there's not a property with a string of 3. So James asked a really good leading question into this. How do you know which ones go on the bottom? Well, we know from properties of exponents that negative exponents go on the bottom. Logarithms with a negative in front go on the bottom. So I can rewrite this as log base 3 of 100 divided by 18 times 50. The 18 and the 50 both go on the bottom. Now, something I haven't said, now of course the property does say this. Do these all have to be the same base for this to work? Yes, if they're not, I can't do this, but they are. 150 divide out, and then the 2/18 divide out. If you do all of that, you get 1/9. Does everyone get 1/9 on the inside?
Yeah.
And again, I am not taking your calculator, even though I'm kind of doing some things on a calculator up here to practice properties of logarithms. You don't have to do that without a calculator. 3 to what power is 1/9? Would you agree -2? And when you're adding, what do? Multiply. Log base 12, 9 times 16, which happens to be 144, correct? Right? And 12 to what power is 144? 2. So that's just some practice with those properties of logarithms with some that you can see the answer to. Any questions so far? Combine the logarithms. This is how you will be tested over this. Not that the last set of problems won't be on the test, but if I put those on the test, I'm going to know that I'm not really testing properties of logarithms because you could just type that whole thing in the calculator. So, and I'm aware of that. So, if I were going to test this, I would ask you to combine the logarithms. Now, have we dealt with any with a number in front yet? No. And I can't combine them with a number in front. There's not a property that has a number in front combining them. Is there a property with a number in front? Yes. What can I rewrite that as? What can I do with that number in front? Where can I move it to? So look at your properties for me. I can move it as an exponent. So everyone agree? Look at that. Is that the last property on the list? So I can move that to be an exponent based on that last property. So step 1, get rid of the number in front. Change it to be an exponent. It does go with both the x and the 1, x plus 1 cubed. And I cannot distribute that as you learned with properties of exponents. You cannot distribute an exponent over a plus sign. You can over multiplication, but not over plus sign. Now, can I put those together? Which property? Subtraction. Remember, if you are putting two logarithms together, don't write natural log more than once, because you're putting them into one logarithm. Did the cube go with the x? On top? No, so make sure you only leave it with what it came with. Okay, any questions about that one? So it said combine into one logarithm, done. As soon as you get one logarithm, you're done. Does everyone see why I had to do the power first? Because there wasn't a property with a number in front. So the first thing I'm going to look at when I look at number 2 is, are there any numbers in front? Are there? So I need to deal with that first. Where is there a number in front? The 1/2. I'll leave this as log of 12, but I'm going to change this to be log of what? Yes and yes. 2 ways you can write it. You can write it as 7 to the 1/2 power, or you can write it as the square root of 7. Why are those the same thing? Because the 1/2 power is a square root. Now, if this were open response, it doesn't matter which way you write it, but if this were multiple choice, most likely they're going to write square root of 7. for that 1/2 power. So make sure you can recognize that. 7 to the 1/2 power or square root of 7, both of those are correct. Now I can combine this into one logarithm. Since there are 3, be careful. Make sure the positive ones go on top and the negative ones go bottom. So the only one that goes on the bottom is the 2. So you get log of 12 square root of 7 over 2. Can I simplify that a little? You can, or you can just leave it square root of 7. Just leave it as it says. What I would do is divide the 12 by the 2. So this is log of 6 radical 7. And I would just leave it there.
What was that first one?
Not simplified. And most of the time, yeah. Let's practice. Now, if it were open response and it didn't say simplify, I'd have a hard time counting off. But most likely it's going to be multiple choice, and you'll have to pick out that simplified answer.
Open response.
You will. On the test.
The big one?
The final, no.
Oh.
But mine, yes.
Oh.
Okay. Try the next one. How's this going? So pretty much we got a new set of rules. Don't make up rules, don't break the rules. Follow the rules. So number 3, what do I need to do first?
Get rid of the 1/3.
Get rid of the 1/3. Move the number in front. And what is 1/3 as a power? What should I write as? Cube root. Good. Now, if you wrote y to the 1/3 power, would you be wrong? No. You would have to be able to match that to the multiple choice answer that had the cube root, but you wouldn't be wrong. It's the same thing. Log base 2, and how would I combine these? Multiply. 5x cube root of 1. All multiplied. All plus, so nothing goes on the bottom. Now we are going to do these piece by piece as we go. Is there a time that you could start to skip steps? Probably. Be careful, but you know, some of you could move the power and combine at the same time, and that's okay with me. I'm not going to do that for note-taking purposes, but if you get where you can, I'm fine. The 2 or the next? The 2 only goes to the x. So, here we go. Log base 7 of x plus 3 minus log base 7 of x squared. 2 becomes an exponent on the x, which I can then write as what? Log base 7 of what? Notice, is there 2 logarithms written there? When I combine them? But not 2 log. Like the word log only should show up one time if I'm combining into one logarithm.
So you only would like when you just put it over the x squared, it's only the x squared. It doesn't go to the whole log.
Right. You don't put. Because you're
square the log, so you just
right.
So what is it?
because the logarithm was negative. Now, quick question. Every now and again I'll have someone who wants to take the negative 2 as a power up. Could you move the negative 2 up as a power and get x to the negative 2? And change it to a plus? Plus x to the negative 2? Would that be the same thing? If you put an x to the negative 2 on top? Properties of exponents, that would throw it down, right? So you're not wrong. Probably a little more complicated thought process. Not wrong.
You simplify that.
No.
Not the exponent x.
Unless you wanted to write divided plus 3 over x squared, but the x squared goes with both, and since you can't divide it out of every piece out of it.
Okay.
I only would divide if you can factor. You can't. Okay, number 5. 2 very correct options. Someone give me the 2 very correct options. Give me one of them. What did I do first? One option. The 2 I could put it with everything. Is that what you were going to say? I could distribute the 2 to everything. Would you be correct? Yes. Or you could combine the logarithms and then work with the 2. I don't care which way. I kind of like putting the 2 in first. 2 log base 5 of x plus 4 log base 5 of y minus 6 log base 5 of z. Step 1, I put the 2 in with everything. And then what? Get rid of all the numbers by changing those into exponents. And last step, rewrite it as one logarithm. Combine it into one logarithm. So I'm only going to write log base 5 how many times? One time. What goes on top? All the positives. So x squared and y to the 4th go on top. Z to the 6th goes on the bottom. If you had worked this with the 2 left out, you would have gotten xy squared z cubed instead of x squared y to the 4th z to the 6th. But what would happen if you squared all of that? Then put the 2 in and squared it. You would get the same thing. So tomato, tomato, you end in the same place. I kind of like distributing that way. You just don't forget anything. And it would work either way. And the last one on this page. So, stick with what we did last time. Distribute that 4. Then what? Move the power, make the numbers in front powers. Combine into one logarithm. Again, if I combine into one logarithm, how many logarithms do I write? 1. I know I've asked that 100 times and you're getting tired of me hearing it, but I hope you hear my voice on the test say, if I'm combining into one logarithm, how many logarithms do I write? Because that's one of the most common mistakes on this part of the test is people will write that logarithm more than once.
What is 2?
When you combine it into one logarithm, there's not.
Like 2 different ones. Because don't.
Then you can't combine them. Any questions about that? See these brackets?
into, okay, I got you.
Okay, cool. Expand the logarithm is going backwards. This is more for your practice than anything, although they do ask it sometimes on the college algebra final, and I will ask it on my test. Last slide is actually more important for real-world problem scenarios, and I'll show you that when we start solving equations and putting some real-world application in this. Expanding is more for you to just practice and understand the properties. But pretty much when it says expand, do what we did on the last slide, backwards. So take it into multiple logarithms. And again, it's kind of for your brain to practice properties of logarithms. As y'all are kind of writing and maybe try the first one, let me talk a little bit about that. I know at some point you stop thinking that this stuff is relevant to real life. Logarithms are probably one of the most important functions that we learn in this class for real-world mathematics. And I know that y'all are thinking, really, logarithms? I've never heard of those before. It turns out logarithms are used in business and money a lot. My husband is an accountant, and he had to take a whole class in college practically over logarithms, just because of how useful it is in the money world. Well, why would it be important? How does interest grow? Interest grows exponentially. So if you're going to solve anything related to an interest problem, wouldn't it involve a logarithm? So if you wanted to know how long it's going to take you to pay off a loan, would that involve a logarithm? Important stuff, right? In fact, we're going to do a project over that important stuff at the end of this chapter, where we look at loans, and car loans, and house loans, and how that would affect your real life. So this is kind of an exciting chapter, even though right now we're kind of in the fundamentals. We're learning how to do layups. It's boring today. But after the fundamentals, this does have a really good application. It's really important for you. How many of you are somewhat interested in going into a business field? Okay. Figured there were a few more than that. So, how many of you might run a business at some point? Okay, so again, more people, okay? And that's pretty important stuff. Alright, so this asks us to expand. So I'm going to take it and break it into multiple logarithms. How would we do that? Okay, it's multiplied, so I'm going to take that property backwards and rewrite this as log base 6 of 2 plus log base 6 of a plus. Good. I'm gonna show an extra step now, but that was perfect. Log base 6 of b to the 4th. And then Hudson said, but hey, I can take that 4 and bring that all the way down and get the complete expansion like I had on the last slide. That is what I want you to do. I do want you to bring those powers down. And if you can see that, like Hudson did, without showing that intermediate step, that's fine with me. You don't have to show that extra step. If you need to show it, show it. We've got options. Any questions about how to expand? Another one that's multiplication. What is this? Log base 6 of
X plus log of z log.
Okay, good. Plus 1/2 log base 6 of z, and I did skip a step there. You don't want to skip that step. That's okay. What step did I skip? I went ahead and maybe I extended it down because that's how James read it to me. If you don't want to do that yet and you want to leave it as the square root of z and then pull it out later, that's fine. Any questions about that one?
I don't get how you did that. Was it because it's a square root?
Mm-hmm.
So it's
So showing this step before this last piece is log base 6 exceed the square root of z. And then the square root is a what? Do you still need to know properties of exponents? And what about this? Okay, 2 ln of a. We're skipping steps again. Does anyone need me to not do that? Okay, so let's go ahead and just do natural log of a squared minus. Okay. Any questions on how she did that? Why are the 2 on bottom minus? Because they're on bottom. That almost sounded like a weird question. The ones on the bottom get negative signs, the ones on the top get plus signs. Doesn't matter what order you write them in. The ones on the bottom are negative, the ones on the top are positive. And then I want to deal with those exponents. So I'm going to take all those exponents and pull them down. 2 natural log of a minus 4 natural log of b. What is the exponent if it's a cube root? Questions about that one? What about this one? Log base 5 of x minus 1. What about the square root, first of all? Is it in the way? I'm not used to having a square root. Could I take it out before I start? What would it be? Since it goes with everything, could I actually deal with that first? If I do that, if I pull that square root out first, what do I have to know about every logarithm I write now? 1/2 goes with all of them, right? Does that make sense? So I have 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1. Or you could have put parentheses around that 1/2 and left it out in front of that word as well. Can I break up the x minus 1 or the x plus 1? Is there a property for that? No. Don't make one up. Don't make up rules. Does everyone know what I mean by that? Not a property where you're adding inside the logarithm. A property where you're adding two logarithms. But not one where you're adding inside. This is more examples. Do we need more examples this way? Or raise your hand if you need any of these examples. It is getting to be a little bit overkill. Probably. If you want another example. Anyone need another one? Combining? Anyone? What about expanding? Does anyone need another example of expanding? Yes? Which one? Anyone? The harder one. Okay, so let's do another expand. So break this up. How many logarithms am I going to get when I break it up? 3. Why am I going to get 3? Because there's 3 pieces in there multiplied or divided by each other. I get log base 3 of 4. And then what am I going to do after that? Do all the exponents. So this is what I do when I expand. and then combine, and which ones go on the top and which ones go on the bottom? Good. The only one that goes on the bottom is the y squared because it's negative. And make sure you only write the log of x2 one time. X cubed and z squared go on the top. Y squared. Everyone understand that both ways? Any of these look hard to you?
No.
How would I do that? Take the square root out first. Get rid of it. It scares me. That's you take it because it scares you, right? So get rid of the 1/2 power out first. That makes 4 of 2x over z. Any questions?
Here in high school, we have one more announcement. Also, happy birthday to Alexis Flipper. Thank you and have a great day.
Why did everything get a 1/2 power? Because all of it was in the square root, and so I pulled that 1/2 out. Now I could have just put a parentheses, and that works too. Just don't forget either parentheses or it goes with everything. One other mental note for multiple choice purposes. Isn't that just a number of some sort? So if you ever do this expansion and you start looking at the multiple choice answers, and they have a number here instead of this, could you go find what that number is? What would it be? Some of you could do it in your head. Others ain't that good. And that's okay. Use a calculator if you like. 1/2 times log base 4 of 2. Okay, now why? 4 to what power is 2? The square root. And then 1/2 times 1/2.